All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, y'all can unpause the video, and we can go over the correct answers. For the factoring, you're going to have x minus 2 times x minus 24, and that's going to be your answer. For the math knowledge question, only members can attend the meetings and no members joined or left during this year. Based on the bar graph, what is the fewest number, the least number of members that they could have? Well, we have 65 members here, but then here we have 72. So we have to have at least 72 members. And then we don't have any more there or there. So we could have only 72 members. That's the lowest number, the smallest number that we could possibly have in our members. Because if every single member came to that meeting, then we would have 72. You wouldn't want to pick 61 because another meeting had more than 61. Actually, 3 other meetings had more than 61. And then the 268, I believe that's just adding the 4 numbers together. It didn't say you only went to 1 meeting. Members went to any of those 4 meetings, and so the absolute least we could have would be 72. Now, how likely is it that all 72 members showed up at a meeting? Probably not very likely, but that is the absolute least number that you could have. Okay, so we're looking at lesson 4 today. We're looking at radian measure of angles, trig ratios for quadrant signs, and then simplifying trig expressions. So radian measures, we're going to review that. Hopefully you dealt with that in pre-cal last year. Same thing with your trig ratios. You really should have learned it in geometry, maybe even in algebra 2. So that should be review. Your 4 quadrant signs, you should definitely have learned last year in pre-cal. And then the simplifying trig expressions, you should have done in pre-cal. The way that it does it may be a little bit different than what you did last year, but all of this should mostly be review from last year. So going back to radian measure of angles. If an arc of a circle has the same length as the radius of the circle, that central angle is said to measure 1 radian. And so here's a picture. If our radius here and this arc length here are the same length, then this angle is said to be 1 radian. And so that's the definition of what a radian is. Your conversion to go from radians to degrees or degrees to radians is 180 to pi. There are 2 radians, 2 pi radians in a circle. So 360 degrees is 2 pi. So 180 is 1 pi, or just pi. Depending on what you're going to, it's going to depend on which one you're going to choose. So we're going to take 40 degrees to radian measure. So we're going to multiply it by one of those 2. We need the degrees to cancel out. So that means that we need the 180 degrees to be down here and the pi radians to be on top so that our degrees will cancel. It's basically like a unit conversion, going from inches to centimeters, or feet to yards, or cubic centimeters per second to cubic miles per hour. Something has to cancel somehow. So then you're just going to use your calculator. So if you go over here to your little calculator, you're going to do 40 times pi. You always want to use the pi button. So if you don't know where the pi button is, it's right above the divide by, but it's in blue. So you have to hit the second button and then the pi. So 40 times pi and then divided by 180. And that's the number that I get. You should get the same thing if you used your calculator correctly. Don't ever use 3.14 unless it says specifically to use 3.14 for pi. And it says write it to 4 decimal places, so 0.6981 would be your answer. So 0.6981. Okay, so that's how you would work through that one. Moving on to your trig ratios. Sine, cosine, and tangent. If you don't remember those, y'all need to pause the video real quick and help each other remember them. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Y'all can stop the video and write those down if you need to, but hopefully you remember them. Tangent is sine over cosine. Hopefully you remember that. If not, write it down. And then you might remember these. Hopefully you do. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And then cotangent is the reciprocal of tangent. I told my students last year, the S and the C on these do not go together. So sine and secant don't go together. You have one S and one C on each of these pairs. And then cotangent and tangent are going to go together. So y'all feel free to stop the video real quick if you need to refresh on those. These are in radians. You might not recognize them. Last year, our pre-cal book used a lot of degrees. So I'm going to put, instead of pi over 4, if I put a 45 degrees there, does that jog your memory a little bit more, hopefully? And pi over 6 is 30 degrees, and pi over 3 is 60 degrees. And the book introduces these, or reviews these in radians. That is because for calculus, just like that, they're switching over to radians. Almost everything this year is going to be in radians. You will deal with degrees some, but for the most part, you're going to deal with radians. And so that brings me to something I want to go over with the calculator while I'm thinking about it before I forget. As freshmen and sophomores, you didn't understand what was going on with the calculator every night whenever you went home and then you came back to class. But I would tell you every time you have to check the mode. And I told you it was because my calculus students were changing it, because you need it in radians and they need it usually in degrees. If you're going to be using sine, cosine, or tangent on the calculator, go to mode, and you see where it says radians and degrees? You are going to almost always need it in radians. If it doesn't specify, probably radians. If the answer doesn't make sense for the problem, go look at your mode and check whether you're in radians or degrees. We're not using the calculator for this lesson, really, for these, but just while I'm thinking about it, I want to throw that out there, that you need to check your mode, because now you're going home and the little freshmen and sophomores are probably changing it back to degrees. So all that to say, you need to get familiar with radians and degrees. These three, pi over 6, pi over 3, pi over 4, you need to get really familiar with, because they're going to be popping up a lot. If you just hate them, you can convert them every time, but it'll save you a little bit if you know the radians and the degrees without having to convert them back and forth. So hopefully you have those written down. If y'all need to pause the video to write them down, you can. Alright, so we're going to evaluate these. So you notice that they are in radians. I'm going to change them to degrees for you, just so that you can, I'm going to help you change them. I'm not going to just do it for you. But that way you can see how they relate. But again, hopefully eventually you'll start to see what pi over 3 is as just a radian angle, and you won't have to convert it. But if we are going to convert it, we're going to multiply by 180 over pi. So your pi's will cancel, and so that's going to become a 60-degree angle. For pi over 4, hopefully maybe you remember it from the previous slide, but if not, you can convert it using your 180 over pi, and it's going to be a 45-degree angle. And then pi over 6, again, you can convert it, but it'll be a lot easier if you just recognize that that's the same thing as a 30-degree angle. So if you want, you can rewrite it as sine squared 60 degrees minus tangent of 45 plus the cosine of 30. I am fine with you changing degrees and radians back and forth. What I would like to see you get away from is having to do this manually every single time. So sine of 60 degrees. Your unit circle that we learned last year, you did it in colors. If you had another teacher, it may have been printed out for you. But 60-degree angle, the sine, anybody remember? Square root of 3 over 2 is what should be coming to mind. The sine of 60 degrees is square root of 3 over 2. And it's sine squared, so whatever answer we get, we're going to have to square it. Okay, tangent of 45, anyone remember what that is? Hopefully you're remembering that it's a 1. And then cosine of 30, hopefully you come up with square root of 3 over 2. So if you don't remember those, you need to either go make a unit circle, go find one on the internet and print it out and study it. Look back at your notes from last year. You need to know the unit circle. Okay, so do whatever you need to. Make note cards, stare at it for hours. Don't go to sleep with it under your pillow. You're not going to learn it by osmosis. But you need to learn your unit circle if you don't remember it. So square this term. We're going to have 3/4 and then minus 1 plus square root of 3 over 2. So that's going to be negative 1/4 plus square root of 3 over 2. If you want to leave your answer like that, that's completely fine with me. The book changes it into one fraction, and so I'm going to do that for you just so that you can see how they are related. I'm going to make a common denominator of a 4. So I'm going to have negative 1, and then this term has to get multiplied by a 2. So plus 2 square roots of 3. And so that's what the book puts for their answer. I would prefer it, but if you want to put that, it is acceptable as well. Okay, so now we're going to look at another example. This one mixes degrees and radians. So you can put them in either one. It doesn't matter to me. So I'm going to go ahead and convert the pi over 6 into degrees. And I'm going to use my brain. And remember that pi over 6 is equal to what? Try not to use the ratio unless you just don't remember it. It is equal to 30 degrees. Okay, so now we've got secant and cosecant. You probably don't know your ratios for those right off the top of your head, but the reciprocal of secant is cosine. So 1 over the cosine of 30 is the same thing as secant of 30. And the reciprocal of cosecant is sine. So 1 over the sine of 30 is the same thing as that cosecant of 30. And so now we can do the cosine of 30 and the sine of 30 into our fractions. So the cosine of 30 is square root of 3 over 2. The sine of 30 is 1/2. So what is 1 over square root of 3 over 2? 2 over square root of 3. And what is 1 over 1/2? 2. And so we can't have a radical in our denominator. We already talked about that in another lesson. So we have to rationalize it. That's going to become 2 square roots of 3 over 3 and then plus 2. To make that into one fraction, the denominator is going to be a 6. No, I'm sorry. It's going to be a 3. And so we're going to have 2 square roots of 3 plus 6 over 3. And so that would be your answer for that one. So hopefully you remember how to do some of those. It'll come back to you a little bit more. You definitely want to practice those so that you can get it right. If you put a decimal answer on these, I'm not even going to look at your work. I'm going to mark it wrong because that tells me that you did not do it how you're supposed to. Only put fractions. Any decimals on these, I'm just going to mark it wrong completely. All right, so your 4 quadrant sines. All smarties take calculus. Some of y'all may remember this from last year. All smarties take calculus. All of your sine, cosine, and tangent are positive in the first quadrant. Only sine is positive in the second quadrant. Only tangent is positive in the third. And only cosine is positive in the fourth. So that's the mnemonic that they give you to help remember your quadrant signs. All right, so look in here. We want to evaluate these. These 19 pi over 6 and negative 4 pi over 3, you may or may not know right off the top of your head, and that's okay if you don't know them. You can use your ratio if you need to. That is completely okay with me. So you can use your calculator, or you can just kind of figure it out in your head, whatever you would like to do. So if you convert it, (19 pi over 6) is the same thing as 570 degrees. And that's using the 180 over pi conversion ratio. And then we have 3 sine of negative 240 degrees. And so we always want it to be in between 0 and 360. You can use negative 240 if you would like, but it makes it a little bit easier if we have them positive. So 570 is obviously greater than 360. And so if you remember from pre-calculus, you're just going to take 570 and then subtract 360 degrees, because those are coterminal. And so 360 is one circle around. And so if I subtract, I get 210. 210 degrees puts me about right here. But if I went another 360 degrees around, that's where the 570 would put me. So it's still the same angle. It's just one more rotation around the circle. So we're going to use 210 and then 3 sine. And we're going to add 360 to this negative 240. And that's going to give us a positive 120 degrees. So if you had me last year, you may have this memorized, or you may have drawn a triangle in the third quadrant. Whichever one is fine with me. 180 degrees to 210. This angle right here is a 30-degree angle. So the sine of 210 is related to the sine of 30. So what is the sine of 30? You should be coming up with a 1/2. But we have to use our quadrant signs. Is sine positive or negative in the third quadrant? Only tangent is positive, so that means that sine has to be negative. So the sine of 210 is a negative 1/2. Okay, now we're going to go to the sine of 120. So 120 is going to be in the second quadrant. If this is 120, then this part here is going to be 60 degrees. So the sine of 60 degrees is a square root of 3 over 2. Sine is positive in the second quadrant. It's the only one that's positive. So it's going to be a positive square root of 3 over 2. So then we distribute. We get a negative 1 plus 3 square roots of 3 over 2. And then make a common denominator of a 2. So we have negative 2 plus 3 square roots of 3 for our answer. Over 2 for your answer. So that's how you can work through those. Looking at another example, we're going to do the same idea. This time they threw in a secant, so we're going to have to deal with it as well. So we're going to start off with the 4 tangent of negative 11 pi over 6. I get negative 330 degrees. And then 2 secant of negative pi over 4. that's going to be a negative 45 degrees. Again, y'all feel free to pause the video if you want to try and work a problem by yourself, or if I'm going too quickly, or if you want to go back, you can rewind it. That's fine with me. I'm not in front of you for y'all to be able to tell me to wait or go back on over something. So for tangent, instead of a negative 330, if we add 360, that's going to become a 30 degrees. And then instead of a negative 45, if you would prefer, you can make it a 315. Although actually on this one, I would have left it like that. But either one of these is perfectly acceptable. Some people prefer, same thing on this one, some people prefer one or the other. There's no right or wrong way to do it. They're both equally valid. So tangent of negative 330 or tangent of 30, that is going to put you in the first quadrant with a 30-degree angle here. Tangent is going to be positive here because they are all positive in the first quadrant. And what is going to be the tangent of a 30-degree angle? Some of you may be saying 1 over square root of 3. Some of you may be saying square root of 3 over 3, depending on which one you memorized. Either one of them is acceptable. I go ahead and put it there because I want it to be rationalized. But 1 over square root of 3 would be just as accurate for the time being right here. For this next one, I don't know secant as well, but I know cosine. And so I'm going to make it 2 over the cosine because we only need to do the reciprocal of this part right here. So you could do 2 and then times 1 over cosine of 315 if you would rather do it that way. Either one of them would be fine with me. I'm going to go ahead and distribute on this first term. 4 square root of 3 plus 3 plus 2 times 1 over, what is the cosine of 315 or of negative 45 degrees? So some of y'all may be saying 1 over square root of 2 or square root of 2 over 2. For this one, I'm actually going to leave it unrationalized as 1 over square root of 2. And the reason is because I'm about to find the reciprocal of it, because it says 1 over that. And if I take the reciprocal of this 1 over square root of 2, it's going to give me just square root of 2. But if I had had it as 1 over square root of 2 over 2, then the reciprocal would be 2 over square root of 2, which then I have to rationalize to be 2 square root of 2 over 2, which is 2. I'm sorry, which is square root of 2. So you can plug it in either way. This method just makes it to where it's very easy to go to just square root of 2. But it doesn't matter to me which one you put. So let me finish my expression. So going from here to square root of 2, I have 4 square root of 3 over 3 plus 2 square root of 2. And then if I'm going to make it into one fraction, the common denominator is going to be a 3. And so I'm going to have 4 square root of 3 plus 6 square root of 2 all over 3. And so that would be your answer. So again, hopefully you're remembering how to do those from last year. They may be a little bit tedious, but hopefully as you go, you won't have to write down every single step. You'll start to condense them a little bit. Okay, so now we're going to look at simplifying trig expressions. You may have done this last year. You may not. All you're doing is trying to turn it into as simple of an expression as you can. So what I recommend doing is starting by taking anything and turning it into terms of sine and cosine. So our first term is cosine squared. That's already in terms of either sine or cosine. So we're going to leave it as cosine squared of theta. Secant could be written as 1 over cosine. So we're going to turn it into 1 over cosine. And then tangent, in terms of sine and cosine, would be sine of theta over cosine of theta. And so then we're going to simplify. This cosine squared in the numerator cancels with these two. It cancels out, and we're left with just sine of theta. So that's as simple as you can make that expression. And you leave it there, and you get to move on. So looking at this one, again, we want to write them in terms of sine and cosine as much as we possibly can. So cotangent is the reciprocal of tangent. Tangent is sine over cosine. So the reciprocal of this is going to be cosine over sine. And then we have a cosine. And then it's all over cosecant. And cosecant is the reciprocal of sine. So 1 over sine of theta is the same thing as cosecant of theta. So if you look at it right now, we can't really simplify anything. However, instead of dividing by this fraction, I can multiply by the reciprocal. So I can make it cosine of theta over sine of theta times cosine of theta. And the reciprocal of 1 over sine of theta is just going to be sine of theta. And then if you look, this sign in the denominator cancels with that sign in the numerator. And then I have cosine times cosine, which is cosine squared. And so that's as simple as I can make that expression. So there's your answer right there. So hopefully some of this trig stuff is coming back to you. You do have to practice it. You definitely don't want to only be using or only rely on your unit circle to come up with your answers. Because you won't be able to use a unit circle on your test whenever that comes up. So your homework is 1 through 25. If you don't have a graphing calculator, make sure you get number 1 and 2 taken care of before you leave class, because those are dealing with the graphing calculators.